Lesson 8, Exponent Laws. So when you have exponents, there's a couple laws that you can use to help simplify your problems. So we're going to start with the first one, and this is the product law. So when you're multiplying together two with the same base, so two variables, your bases are the same, you add your exponents. So for example, we have x and x, the bases are the same, so we're going to add our exponents, so x to the 4 plus 3, which means it's x to the 7. So simplified together, it's x to the power of 7. When you're dividing, you of the same base, you are going to subtract your exponents. So we have the same bases, so we're going to subtract our numbers. So it's going to be x to the 6 minus 3, which is x to the 3. When you have a product, a power of a power, so something to the power of something to the power of something else, and you can usually tell that because they're right beside each other, you're going to multiply your numbers. So we're going to multiply, so this is going to be x to the power of 5 times 2, so x to the power of 10. And when you have a fraction, you distribute your exponent to the top and to the bottom, so to the numerator and to the denominator. So if we distribute our power, this will be x to the 5 over y to the 5. Now we're going to apply these to do more complex problems. Okay, for the first example, something that you have to keep in mind is order of operations. So bed mass. If you need to make a note of that. So we have to do inside the brackets first. So inside the brackets, we're going to distribute our exponent to the top and to the bottom. So we have 3 to the negative 4 over 2 to the negative 4. And because it's a negative exponent, what am I doing? You have to do the reciprocal, so we might as well make it positive. So flip it, so it's 2 over 3 to the negative 4, or to the positive 4 to the power of 2. And this one would be distributed, 3 to the power of 2 over 2 to the power of 2, all to the power of 3. So we're going to distribute this in now. So 2 to the power of 4 over 3 to the power of 4, all to the power of 2, times 3 to the power of 2 over 2 to the power of 2, all to the power of 3. Now we're going to distribute once again, but because it's a power of power, we're going to multiply. So this will be 2 to the power of 4 times 2, which is 8. And to the bottom, it'll be 3 to the power of 4 times 2, which is 3 to the power of 8. The next one, we're going to do the top to the bottom, so times 3 to the power of 2 times 3, which is 6, over 2 to the power of 3 times 2, which is also 6. Now I'm going to bring it up here. So we have 2 to the power of 8 over 3 to the power of 8 times 3 to the power of 6 times 2 to the power of 6. Now because we're multiplying and our bases aren't the same, we're going to just rewrite this as one fraction. So on the top we have 2 to the power of 8 times 3 to the power of 6. And on the bottom we have 3 to the power of 8 times 2 to the power of 6. So now we can divide. So here we have the bases the same, and here we have the bases the same. So we're going to subtract our exponents because we are dividing. So 2 will be to the power of 8 minus 6, and 3 will be 6 minus 8. 8 minus 6 is 2, so we have 2 to the power of 2, and 6 minus 8 is negative 2. Now because we have a negative, we have to flip it and put it on the bottom. So the 2 stays on top, and the 3 goes to the denominator. So what this is the same as is 2 to the power of 2 over 3 to the power of 2. And we can even simplify it more 2 squared is 4, and 3 squared is 9. So if you were to evaluate and simplify our original equation, you'd get 4 over 9. For the next example, we have the expression x to the power of 3, y to the power of 2, multiplied by x to the power of 2, y to the power of negative 4. So what we're going to do is we're going to multiply our similar bases. So we have x's and y's. So the x, because we're multiplying, we add our exponents, is 3 plus 2. And our y is 2 plus negative 4. And 3 plus 2 is 5, so we have x to the 5. And y is the same as 2 minus 4, which is negative 2. Because y is negative 2, we have to move it to the denominator, so we have x on the top and y to the power of 2 on the bottom. So this is our simplified expression. For the next example, we have a coefficient in front. So all we're going to do is we're going to divide the like terms. So the coefficient is like, the a's are like, and the b's are like. So we're going to keep them all separate. So for the a's, we have 10 divided by 2. For the b's, we have a to the power of 5 minus 2. And to the b's, we have 3 minus negative 2. Now we're going to simplify. 5 divided by 2, or 10 divided by 2 is 5. 5 minus 2 is 3. And 3 minus negative 2 is the same as plus. So 3 plus 2 is 5. So our final simplified expression is 5a cubed b to the power of 5. For the last example, we have 8a to the power of 3, b to the power of 6, all raised to the power of 1/3. So we have a power of a power, so we're going to distribute 1/3 to each term in the expression. So you have 8 to the power of 1/3, a times 3 times 1/3, a to the power of 3, sorry, and b to the power of 6 times 1 over 3. 8 to the power of 1/3, remember this is our m and our n, and we have n, root is the index, and m is the exponent. So we have 8, and our index is 3, all raised to 1. Now we have 3a to the power of 3 times 1/3. These cancel, and this is just 1. 6 times 1/3 is the same as 6 divided by 3, which is the same as 2. So we have b to the power of 2. And the cube root of 8 is the same as 2 times 2 times 2. So because we have 3 2's underneath, it's a perfect cube. We bring out 1 2, we're left with 1a and b squared. So this is our final simplified expression.